Aloha, Richard Halverson here. This is ICS321, and today is the 20th of January. This is the second video of the semester. Let me share my screen. And see, I think I've just put up resources. Make sure it's visible. Yeah, here's the fall 2021 playlist. And the textbook was pretty similar in fall as it is this semester. Let's see, let's look at where we are. I did do a video already on how to do the first lab 1.6. And so you can watch that. It's not that long. It's challenge activities. Okay, so so we should be like around it. So I'm going to talk about chapters 1 and 2. I don't know how much deeply I'll get into 1. You know, a lot of this stuff, a lot of this early stuff in this textbook, the textbook, along with its participation activities, can do a lot better job of explaining it than I can sometimes with some of this stuff. And I found sometimes I've only confused people by trying to explain it in similar to the way that I learned it. Anyway, so but I noticed I don't say anything about participation verification. Okay, what's very important in this class, it's important because it's a federal law now that we have to verify participation of students because if we can't verify, or if we have not verified your participation, then I think it might be easier, like, for you to get your money back, or there's a bunch of things that are to protect you as students. So I think it also has to do with scholarships and so on. But anyway, so I would like you to go to the forums and enter in why you're taking the course. And I think 44 of you have I recorded all 44 of you? I think I have. Oh, wait a minute. Let me see. Did I get everybody now? Forums. Because there's only about 47 people in the class. So I guess 3 of you haven't filled it out, and I have. Okay, there's only 1 of you. The last person who filled it out, I have not recorded you, but I'll record you right after this class is over. But anyway, all you got to do is say why you're taking the class. And, you know, I'm taking this class because I needed to graduate. I mean, that's a good enough reason. I just need to know that you've started. And, you know, you get credit for participating in the forum. So you gain points by answering that simple question. But, you know, this is for your colleagues to read also. So, you know, you may want to say a little bit more about why you're taking the course, maybe what it is about databases you're interested in, or how that fits into what you would like to do in your career after you graduate and so on, or maybe you've already graduated. All right, so so let's go back to the syllabus, and oh, let's look at the assignments. I've loaded up the assignments too. And so I might start you out on some of these a little bit. The first one, of course, you've already looked at. If you've looked at the first video, you're supposed to set up your it's in what's called your htaccess file. Your to make sure that when you go to your website, you know, I don't think I did talk about this at all, did I? Is there can somebody write in the chat whether or not, if you've watched the first video, did I talk about how to do the first assignment at all? Because if I have it, I can just quickly do that too, because that'll get you started. It's getting programs to run on your server. But anyway, in the meantime, if somebody would like to answer that question, or maybe if you have the video, it's okay. Let's open up the textbook. I have to go to the syllabus.
Sorry, I have a question about the auto grading.
Yes, please. Yes.
For the lab, so like I didn't know there was a video, so I unfortunately haven't watched it, but I did do the that lab assignment, and it says there's an auto grader. It just says like you get 10 out of 10 or 1 out of 1 points. Is that supposed to go immediately to your La Lima, or does that happen later?
Yeah, it doesn't go immediately to your La Lima. In both auto graders, in both the textbook and in the auto grader that I wrote. No, they if it says you got 10 out of 10, then that'll be what you get. I have a control panel that I'm going to show you the control panel. Maybe I can. I better not do that. Let me see if I can show you a CS. Okay. I'll show you fall. Yeah, I can show you fall. I can show you part of fall. So what? So well. Let me go to. Okay, here's mine. Okay, yeah. See, I don't want to show you anybody else's score. Oh. Okay. Okay, here is, I have a control. I don't want to show anybody else's grades. So. Okay, look. Okay, so I have a control panel that looks like this, except for I've got everybody. In fact, I think this is fall also, but I've got everybody. And so like okay, so here this is me. I've done these. So I got 10 out of 10 here, so it's just 20. It's 100, 100, 100. So I should see 100, 100, 100 here for all of you, and then I know that you got all the points, and it's pretty easy. You just keep on working at it until you get all the points, and if you can't get all the points, then either email me or you can post it up on the forum. I don't know how much in this class, how much you guys use the forums. But with these forums, if you have a question that you want to ask that you want to ask about how do you do this, or I'm stuck with this, you post it up on the forum and anybody can answer. Okay, so if you look at the forum and you see a question that someone asked and you can answer it, then you can answer it, and participation in the forum gets points. Okay, it encourages, this is a asynchronous online class, and there should be interaction between students, and it's tough to do that in classes like this. So that's kind of what this is for. So I go in here every now and then, and I look at stuff that's specific to me, but lots of times when there's a question about a problem or an assignment, then there are students that where if you, and you probably this way too, if you got that answer, you kind of don't mind helping others, with problems that they're having. Yeah, so I'm going to try to get those auto grader get the grading points over like once every maybe every couple of weeks or so, maybe after every assignment is due. These posted due dates for these assignments, you know, as I've mentioned, auto grader assignments, since they're auto graded, and since it only takes me about 5 minutes to copy the scores over from the auto grader to Laulima, you know, in there and compute it in your grades. You know, I don't, you know, you can one of the few classes, or if you hand your stuff in late, you still get all the points. That's not true for the form questions, because I have to grade those form questions manually. So if you want to get the points for the form questions, I don't know how much points it is. Maybe it's 10 points or something. Just participate, but try to get all your participating done like before finals week, because well, first of all, it might not help much in, well, no, it's actually, it may help during finals week, because finals week, you know, everything is due. All the auto graded stuff is due, you know, at the end of finals week. So, you know, you guys might decide that you're going to jam hard on your other classes first, because those professors are more strict with their deadlines, or you're handed in stuff that they got to grade manually, or there's a grader involved, a TA involved is grading, and that TA's got their schedule also to deal with. And but not in this class, because I've invested heavily in auto grading technology, and I've been doing this since I started teaching, and I came back to academia and started teaching again in 2012, and I got interested in this. Anyway, so and because it's easier for me, you know, I put a lot of investment in making the auto grader, and I'm always tweaking the auto grader. In fact, I've already tweaked the auto grader. I don't think I've done it yet for this class. No, I haven't done it yet for this class, but for my other two classes I have. Anyway, so there's a lot of help for you in taking these classes, and everybody should get an A. It's nice over here in Manoa, because there's A pluses, A's, A minuses, B plus, B. At the community colleges, there aren't those pluses and minuses, and so if somebody doesn't make an A, then it's a B. If somebody doesn't make a B, it's a C, and you know, it's kind of hard on people sometimes. So this textbook is they add new stuff every semester, and they've done that again this semester. What they've added is a lot more labs. Previous semesters, there was only like, you know, 10 or 15 or so SQL problems, and I stuck all those in chapter 3, because that's where you teach SQL. In fact, I've taken this basic textbook and I've moved stuff around, because I want you to actually start doing some stuff in the beginning of the semester, that as opposed to waiting until you get to the point where you're smart enough with SQL where you can start doing assignments. I've decided that it's better just to immerse you into SQL as soon as you can, as soon as it's feasible. And because really what you got to get out of this course, the practical knowledge you have to get out of this course, is how to write SQL statements. Okay, and this is a very close second, is how to take a database problem and design a database that's in you know, a high normal form, a third normal or BCNF form, to eliminate the possibility of having redundancies and inconsistencies in your data, which is what databases are good at. And but there are now labs in all of these sections. Let's see, how can I show you? I guess I can't show you that in this one. I can show you that in this one over here, though. This is my the instructor version, or the instructor Zybooks. And so if we look at reporting over here, we can see from here, these are all the chapters, And the participation exercises are the real simple ones that all you have to do is click through them. And once you're done clicking through them, you get all the points. And then there are these challenge exercises, and they're a little bit more challenging. You know, you might get them wrong, and then you're given another chance. The data is a little bit different to get those right. But then these labs are actually where you have to write code. And in this class, in this textbook, the code writing is writing SQL mostly, or writing SQL. It could be writing SQL to create statements and to create database tables, to create databases, to search, select data out of databases. And are we going to get into any no, we're not going to get into any, not in this book. We don't, doesn't look like we do any kind of stored procedures or anything in the textbook. Okay, so what this is here, database programming, this is, for example, using Python to connect to a database so you can send it SQL statements. And so we're going to do that in Python. And if you don't know Python, you're going to get a nice taste of Python. Don't worry about it if you don't know it. I'm going to give you enough of everything so it'll just be an enlightening experience for you. I hope my internet connection is okay. I keep getting this internet connection is unstable message. What's my date network? I'm on a bad network. I'm
it's a bit laggy, but we can still understand you.
Okay, I'm going to switch to my other network. Okay, hold on. All right. Can you hear me?
Yep.
Okay, good. I'm on my Spectrum. I've got Spectrum and Hawaiian Tel coming into my house. I live way at the end of way east Honolulu by Sandy Beach almost, and out here, you know, it's really bad internet. So I end up signing up for, I used to switch back and forth because I'd be convinced that the last internet provider was better than the one I had now. So I was switching back and forth between Spectrum and you know, Oceanic and Hawaiian Tel. And finally I said, I'm just gonna have both, and I switch back and forth, and it's not usually the case where both of them are bad at the same time, which is fortunate. So so we aren't going to learn stored procedures or triggers in the textbook, but we are going to learn them in our assignments. Fortunately, we're going to learn them in our assignments. And so in assignments, here is where we start writing some stored procedures and some triggers, and then we're going to do some. And here with these APIs, these are actually, you know, implementations of, you know, PHP and Python, just like what we're doing in this, what I was showing you over here. See, so there's kind of two levels of database application programming. There's programming that you do in a language like Python or Java. Oh, Java, cool. So in our assignments, we're doing Java and PHP. PHP is probably more worthwhile language for you to learn anyway. Just probably more of that right now for web-based stuff. But then before this, in assignment 6, for example, we're creating stored procedures. So here's a stored procedure. See how much I give you? I give you all this. This is a stored procedure, and you just got to fill in these things. Isn't that so? It's pretty easy, and plus I carry you through it. And plus there's a video here. What this video is. Let me do this. They put my videos behind commercials. Well, anyway, skip the ads. So I'm pretty good.
Aloha, Rich Alverson here. This is ICS321.
Good. I'm glad I'm not wearing the same shirt. All right. All right. So And there are two store procedure assignments. The other store procedure assignment's actually a little bit easier because there's statements here that you got to fill in. But I give you the statements down here. So you got to figure out which statements got to be plugged in where, okay? And so after a while, you learn what's actually going on here, and it's pretty easy to figure it out. But it's kind of an easier way to learn about stored procedures. Stored procedures. They're small. They're small, and they're things that could very quite easily be implemented using a higher level language like Java or Python or PHP, and you're just sending SQL statements to the database through an API, and the kind of API that connects the programming language to this database. But you may want to enforce some things. Like one of the things you might want to enforce is, and I'm so glad I did this back in 2005 when I created this system for an organization here in town. They're still using it. It's a database management system. It's a membership management system for their organization. And back then I decided whenever and lots of people could make updates to the database. And so I put a thing in there whenever anybody, went to the form to whatever to update a member record or update anything, that information was stored as a single line, summarizing what was updated in the database into a table, and stored forevermore. And it's been so helpful because it's not like you're finding if somebody did something to the database that they shouldn't have done, or it's not like you're looking for people that are intentionally doing anything wrong. You find that people just make mistakes, and they do something that they thought they were doing something else, and they do something different and ends up messing up the database a little bit. But something like that, where you want to record whenever a member or whenever somebody makes an update to something, that's a perfect stored procedure kind of thing, because you put that all the way down into the database itself, and it doesn't matter who's writing programs to access the database or anything. It's like, if there's a new entry in this table, we store some other stuff in some other, record keeping tables, and keep track of things like that. So anyway, you'll see these examples are pretty, these assignments are pretty good for you to see how they're useful. But anyway, let's go over the let's start going over the chapters of the book a little bit, so you can get an idea of how this textbook works. So you can watch the video on how these iBooks work. I'm pretty sold on them. So here we start out by talking about data, blah blah. Most data is digital, so on. Okay, so here examples of public data sets. There are these public data sets that you can access, and this is in this class. I guess we're not going to really get into any of that, but you're going to learn how to write APIs and how to interface to APIs. So if you actually want to write programs to access these public databases and get data from them and manipulate them and create reports, or have them be part of your reports, you're going to learn everything that you need to know to do that in this class, although we aren't going to actually have any assignments that do something like this. But okay, so here's a participation exercise, and it's a required thing that you do to get all the points. And all you do is you click through it. Here, start. In fact, you can do it twice as fast. And you just sort of click through, and you're learning something. You should step through this. That's the idea. Different types of data. And then this is a third kind here, which is NASA data and so on, light measurements and so on. And the checkbox appears, and I got all the points, and I learned something. Here's another kind of participation activity where you drag these things into here. It's kind of fun to do. And when you do it, you get all the points. Let's see, provides more than government data sets. Cancer. Cancer. Owned by Google. It's not that. It's not that. Must be this. Numerous data sets on aerospace, earth science. Must be this one. And then New York City must be this one. And I got all the points. See. So here are some definitions. Database system, database management system. There's a query language that we're going to use, and it's a specialized programming language designed specifically for databases, and they differ significantly from general purpose languages like Python, Java, and C++. Query languages are, you describe what you want the result of the data of the query to be. You say, I want a table that's got everybody in my organization. It's got everybody's first name and last name, an address in the human resources department, and that's what you say in your query. And then you say submit, and it comes back with that. And so you've defined what you want. You define the columns, define what kind of rows you want, and it figures out how to find the answer to your question. That's not like a regular programming language. For a regular programming language, you'd start writing code to loop through to, you know, connect to something and bring down all the data, loop through, pick which fields you want, and only add data to your report that's people from the human resources department and so on, and then it's done. So in regular imperative, or in the regular programming language that we write code in, you know, like Python, so on, those are there we actually write the procedure on how to do something, whereas in database languages, you don't. It's a different approach, and that's why I believe some people who are computer scientists, they're not super good at writing a sequence of statements to complete they're not that good at computational thinking. They may be better at mathematical thinking, where they can write the equation, they can see the whole big thing and how it can all be expressed in one statement, one great big select statement that's got a whole bunch of subqueries in it, you know, and they can see that and write those kind of statements. Whereas other people, that gets too complicated for them, but they can write a sequence of statements. So that's one difference between programming in database language. The other thing about what's nice about SQL is that once you learn SQL, that's it. There's not going to be any new database programming language coming along in 10 years, like there will be. I mean, right now, Python is the big programming language. Well, 10 years from now, probably sometime before I'm done teaching, it'll be something different. And so, you know, it'll be the next hot language. And Python hasn't always been that hot of a language, but it's a really good language for various reasons. Anyway, so we're going to learn about that. So you want to make sure you read all these things and click through them, and you just want to click through them because you're gaining the knowledge that you're supposed to learn, the student learning outcomes for this course, and it's a pretty simple way to do it. And also, even if you're it's the end of the semester and you want to get a few more points and you're tired and it's late at night, you know, you don't really have to think that much to get the points, because you can just click until you get the right answer. You know, you just click until you get the right answer. You can do that if you want to, but of course that's not a good way to do it. You should read it and understand it, but it's not like you get anything marked off for not getting the right answer the first time. So here are some database roles. You know, these two kind of go together. And this is somebody that might not be a database designer or programmer, but just, you know, understands all about backups and granting access and all that kind of stuff. And then of course there's the users. That's everybody. Although a programmer is oftentimes considered a user of the database. So here's you know, something that you understand about the roles. Click through this. More questions. All right. So you should just click through this and make sure you get a good idea of where we're starting from. Let's see what else, see if there's anything important here. Now I did go through, let's see, query languages. So it's a nice exposure to, there's 4 different languages, 4 different statements in SQL. There's inserting into the database, or inserting into a table. A database can consist of lots of tables, but you're inserting into a single table. You're updating a record in a table, or you're updating some records in a table, a record or some records. You're selecting data out of the table. And when you select the data, you specify what columns you want. You specify a where clause, which restricts the rows that come back to you. You usually don't want all the rows of a table. You only want some rows of the table that fit certain criteria. And so that's the select statement. And then of course you want to deal with delete records. So those are the 4 different kinds of SQL statements. That's all there is. Now, you know, they can get complicated. There's a where clause, and there could be subqueries. Create, read, update, and delete. It's not that hard to remember that. So it's called structured query language, SQL. These are the 4 statements: insert, select, update, delete. We have various forms. In this form of the insert statement, the order of the columns in the table matter because you're putting them in order. And that's not really a preferred way of thinking about these database tables, because these database tables really are more like sets, or you know, where like order shouldn't matter. Is a table different if the name field comes first and the ID field comes second and the balance field comes third? But you know, the intersections of the row and the, you know, so no, but there are these ways of writing these statements that are shorthand, you know, notation to make it so you don't have to, you know, write so many characters. But anyway, you can see what this does. This ID of 290, the name is Ethan Carr, and the balance is that. Here you're selecting just the name. The account is the table. And you only want those where the balance is greater than 3,000. So that's just going to give you Raul and Ethan. Here we're deleting. See, so there's this where clause. These where clauses are common in all these kinds of statements. In these 3 statements, there's no where clause in here. The other thing is that in database languages, there's this mathematical concept of closure, where you know, this select statement produces something that looks exactly like a table. It is a table. This select statement produces a table. In fact, it's going to produce a table that's got 1 column and 2 rows. Okay, and we are selecting from a table. Okay, now so that means that this here, I mean, it doesn't necessarily mean this, but with concept of closure, the property of closure, this here has to be a table or something that looks like a table. So this here can actually be another select statement. you know, in parentheses or something, you know, something in there in parentheses that produces something that looks just like a table. And that's where you get, where you can get subqueries. So you can have a select statement there that produces a table, and then once that table is produced, then this outer select statement operates on it, okay? And also things like this. This is a scalar value. It's a value, right? It's like an integer value or a number. Well, it's possible to have a select statement that produces just a single number. Like, for example, select balance from account where ID equals 290, okay? Select, not name, but balance. So you're selecting this from an account where, and you have a where clause where it's only going to be guaranteed one record. So let's say your where clause is ID equals 290. Well, that's going to produce one value. It's going to produce 5,000. Well, that's one value. This is one value. That means for this, you can put another select statement. You put in parentheses, select something, and then it produces a single scalar value, and that gets plugged right in here. And then the outer select statement can work. So that's where it starts getting complicated. But I've just told you everything about all the SQL statements that there are. So it's all about that, and things just get more complicated. Yeah, just more of it. So and then there's different ways of writing insert statements a little bit. They're all obvious. You'll see them when you. In fact, here the update statement, updating account set balance equals to 450. There's a form of the insert statement where you say insert into account set. You could say set ID equals 290, comma, name equals Ethan Carr, comma, balance equals 5,000. You know, that's another form of the insert statement that I like it because it looks a lot more like the update statement. The trouble with this form is you got to just know that this is the ID field and this is the name field and this is the 5,000 field. And, you know. So this is a nice challenge activity which you can, you know, click through and get all the points for it. There's 4 points for four challenge things here. Okay, here's how you create a table. Now you create the template for a table, but it doesn't have any rows in it. And then after that, you insert the rows. So first you have to create the table, and then there's a table there, and you can insert rows into the table. So this statement that you use to create the table looks just like this. Starts with the words create table, and then there's the name, and then there are these field names or column names, and each of them have types. And the thing about databases, which is different than spreadsheets, is they are really super strict on these types. Okay, they're so strict that if you try to put something, if you have an integer field and you try to put a letter, in there, it'll just reject the whole thing. It'll be like you never even tried. Okay, and that's one of the big selling points of databases. There's this, and you'll learn more about this in one of the later chapters, this where the state of the database is always in a defined correct state. So let's say that you have an insert statement and you're trying to insert some letter into a field that can only, where it's defined as an integer, and you try to put a letter in there. It'll and halfway through its execution of that statement, you know, the power supply blows, and you know this or the building blows up or something. A database management system goes through great lengths to ensure that if there is a failure, that when the failure is recovered, the database will be in a correct state. So it'll either be able to finish what it started, or it'll be able to roll back to before it started in the first place. some database operations might be doing 2 or 3 things, you know, 2 or 3 things on it. First, it does, it's like, let's say you want to move some money from your savings account to your checking account. Okay. So the first thing it does is it debits your savings account and then it credits your checking account. Well, what happens if it debits your savings account and then the thing goes kaput? You know, it's like, where's my money? The database management system has got built-in stuff down in the very, you know, guts of it, where it'll be smart enough to roll back where it's like you never took the money out of your savings account in the first place. So it's like the transaction never started. Anyway, we've got another 15 minutes this class. Okay, so that's creating tables. So here's an example of you're create a table and you insert some stuff, and then here's a select statement for just displaying out all the stuff in the movie table. This is a select state. It's got an asterisk there. It's got an asterisk. That's default, meaning all the columns. And then there's no where clause here. There's no where clause. So it's going to just display them all. If there were the where clause, then it would only be displaying, it would only return back to you what is allowed by the where clause. And what's great about these, do we get to see this thing run? Oh, okay, so this thing actually runs. So this first it created the table, and then it inserted these movies into the table, and then it did this select statement. And the select statement displays out all of the, this is the table after it's been created. And then this is the result of the select statement. So, and what we should be able to do is to, and all queries are supposed to end in a semicolon. But you can say where, and I'm just going to show off here a little bit. I'm going to say title. Let's see, where's something that's too old? Where's PG? Okay, where rating is like. Now I'm going to be fancy here. Like starts with PG, but then it can have anything after it. Okay. There. So it starts with PG, but then it can have either nothing or anything after it. So the result of this should give me, well, let's just see what it gives me. It should give me everything except for Toy Story and Godfather. And so it did. So it gave me all the PGs. And let's say we only want the title and the rating. You can be fancier here and stick some. I don't want all those columns. I just want the title. And the release date. Let's just say I just want that. So that's how these select statements work. Anyway, so let's so when you're designing and programming a database, there's first this analysis phase, and you're supposed to, logical design, physical design. We can make entity relationship diagrams where we have all the tables here, and entity relationship diagrams. So these sort of describe the relationship, and there's terms for these: rights, cells in, cells to. Rectangles represent entities, so this is like a table. Entity names appear at the top, it's like the name of the table. Lines between rectangles represents relationships, like authors write books, and books sell. Where's the store? Okay, so these books are in a store, and then they sell to customers. And so you may want to have, so somehow the relationship somehow the database can, you can represent these relationships in a database. It has to be able to take care of, manage things like, very good. You know, you can come and go anytime. You notice Raphael had to leave. You can come and go anytime here. In fact, you know, I'll let you in on a secret. There will be days when nobody shows up. Okay, it's okay. I just record. Sometimes I'll start over again. You know, I'm start my class. I'm recording away, and then I'm talking for 5 minutes, and I realize I shouldn't have even started talking about this. I'm wasting their time completely. And if nobody's there, I'll just stop it and start over again. So sometimes you'll notice, sometimes you might notice in a recording that, gee, he started 10 minutes late today. Because of that. So you want to make sure you understand the difference between an entity, which is the whole table, the relationship, which is this thing here, how one table is related to another table, and then an attribute is just like one of these things in the table. Like an author has got an attribute, or he's got a first name and a last name, 3 attributes, kind of thing. And then the logical design of the table, there's things like an author can author more than one book, right? So you don't want to have so you don't want to have all of the books that an author wrote in the author table, because how many fields would you set aside for each book that an author could write? So but let's say, okay, also a book can be authored by more than one person. So the way you would actually implement this thing is you have an author, and you have a book, and then you have this other table in the middle which connects books to authors. So this way a book can have multiple authors, because in this book author table you just have multiple authors all pointing to the same book, and then an author can be the author of multiple books. You can have in this book author table, you have you know, a bunch of records all going to the same author and then going to different books and so on. Same with here, you can have books selling to many customers and customers buying many books. And so now if okay, you may have for a publisher, you may have that a book can only be published by one publisher, which most of the time is true. In that case, you could put the publisher of a book in the book table. Okay, you could put the publisher in here if there is only one publisher for a book. And you would not have something like that. You would not have the books that a publisher published in the publisher table, because a publisher publishes, you know, hundreds and thousands of books probably. So then there's this physical design, and we are not going to really get into this into actually doing any of the physical design, but we have to understand what these components are, because we are going to be wanting to make indexes sometimes for our tables. If, for example, if this table is searched by title, you know, a lot, then you may want to create an index of the book title to make it easier to locate a book, because an index creates a sorted version, and that way you can use a binary search to find what you're looking for. And then there is programming APIs. There are 2. Does it talk about? So talk about this. There's 2 definitions. There's 2 kinds of APIs, and most SQL implementations are not object-oriented. To write a database program, SQL is usually combined with a general purpose programming language, such as one of these. And so in these general purpose programming languages, there are application programming interfaces, which are really, could really call them database programming interfaces. And it was where the application is a database. Database programming interfaces, and this is for programmers who are writing programs in one of these regular higher level languages, and you want to interface to the database application programming interface, or API. And so you learn about these are certain. You have to have a import someplace and importing database stuff, and we're going to do all this. Okay, we're going to do all this in our labs or in the assignments. Okay, and then we'll get to the other kind of APIs later, but that's different than these APIs here. These are also APIs, but it's a different meaning of API. It's the application programmer is like the web programmer, and the API is this component, this little bit of code that sits on the server that handles all the database, the database interactions for you. But it's written in a higher level language itself, and you get at it by sending it, HTTP queries and so on. Like this. We'll get to that later. All right, so that's section 1.4. Section 1.5 here, we just are, and this talks about, MySQL that you can install on your machine if you want to, and Workbench, MySQL Workbench, you can install that on your machine if you want to, but you won't have to do that because you can just use the server that I provide for you in class. And by the way, this is the first semester for this textbook that has this Sequila thing, and where they actually want you, the textbook this semester, they want you to install MySQL on your home machine, so you can certainly do that if you want to, but you don't have to. This talks a little bit about that. Welcome to MySQL Workbench. And I covered some of this in the first video of this semester. Okay, and here's 1.6. I covered this in the first video. Okay, so you can go and read the first video. Okay, well, I hope this helps. Thanks for watching.